Well, we did square roots. Guess what's next? You got it. It's got to be cube roots. So same thing. Rewrite everything as a product of its primes. And now, because it is an index of 3, you look for triples. Okay, so let's look at this one. Take a look. We got the cubed root of 81. If you break that down, that's 9 times 9. And if you keep on going, you know that that's 3 times 3. There's times 3 times 3. So look for triple. So do you see how many we have? We've got 4 of them. But that index is the thing that tells us we only need 3 of them. So just like before, take one representative out, put the original root down, and tell me what's left. Look at that. That's 3 cubed root of 3, and that better give me the cube root of 81. And in fact, it does. Watch again. Let's break down this 54. 54 is easy. That's 9 times 6. That's 9 times 6. Now, check this out. 9, of course, is 3 times 3. 6 is 3 times 2. Check it out. You are looking for triplets. 1, 2, 3. There's your triplet right there. And guess what? One representative out. Good for you. Leaving you with, guess what? Under the original radical, 2. Done. There you go. Getting from entire radicals into mixed radicals is not tough. All right, here we go. Let's do one that's a little tougher then. If you look at this one, you're going, well, last time we at least been able to square root, when we're square rooting, we can go like divide by 2 or something. Well, this is a huge number. But if you think about it, it ends in 5. And as a matter of fact, it ends in 75. So this thing's actually divisible by 25. This works out to be 25 times 15. Pull out your calculator. Check it out. You'll see it works really, really well. So this is 5 times 5. This is 5 times 3. Do you see the triple yet? I do. There's the 3 5s. Pull that 1 5 out as a representative of those 3 5s, and then this is cube root of 3. And that's how you do those. It's really, really cool, and it works for any index you want. Case in point, look at these ugly questions. Oh my gotcha! Holy smokes. We're looking for the 4th root. So guess what you're looking for? You're looking for 4s. That's what you're looking for. So break this down, 162. Now, you might want to pull out a calculator for this because you know what? If you start dividing by 2 all the time, it's going to drive you crazy. So I'm going to pull out 162. Here's my calculator here. I'm going to pull out 162, and I'm just going to start dividing by some numbers just to see what works. I'm going to try, I don't know, I'm going to try 12. Let's see if it works. Nope. How about 162? Let's divide this by maybe 16 and see if this works. Nope, that doesn't work either. So you can keep going and going and going, but I went down to 162. You know, sometimes you might just have to divide by 2. Look at that. It gives you 81. Oh my goodness. So 81 times 2. Now the nice thing is, I know 81 is 9 times 9 times 2. Look at this. This is 3 times 3. That is 3 times 3 times 2, right? Now, check it out. You are looking for groups of 4. 1, 2, 3, 4. And just like before, you take one representative out. There's the 3. Leave whatever is left under the original radical, which is 4 root 2. Now, don't forget, you had a minus 5 up front, so you still have to bring that minus 5 down here. So it's minus 5 times 3 works out to be minus 15, 4th root of 2. Oh my goodness, that looks like, awful. Well, it's a lot nicer than this number, I think, up top here now, isn't it? Okay, well, let's do the same thing for this. This one tells you you're looking for groups of 5. There's 486 again. You're going to be stuck with 486. So pull up your calculator and see what goes into 486 nicely. Now, to save you some time, I went through some possible numbers. I went 46 divided by 8. That didn't give me a nice number. Then I went 46 divided by 2. Too big. Then I tried, well, how about 486 divided by 9? Look at that. I got 54. So if I go back to my original, I know that this 486 is 9 times 54. How beautiful is that? And I know 9 breaks down to 3 times 3. 54 breaks down to 9 times 6. So check, look what I got. I got 3 times 3, right, from this one and this one. I got 9 breaks down to 3 times 3, and I got 6 that breaks down to 3 times 2. There's your prime factorization, just like before. But now I'm looking for groups of 5. 1, 2, 3, 4, 5. I'm going to take all the 3's out. Look at that, because there's a group of 5 of them. There's my 3. Original radical index was 5. Square root, what's left? 2. And that's how you do these kind of questions. So it doesn't matter what the index is, always look for the product of primes and then look for how many indexes, how many of these things correspond to the index that you're given here. That's how you solve this for any question out there.